Okay, let's do an example problem here in which we consider a circle. Okay, and for the circle, I'm going to cut it into fourths. And I'm going to throw away two parts of it. So I'll throw away that part and that part. So what I've got is I've got a fourth of a fourth of a circle here. I've got a fourth of a circle here. Okay, and let's say the radius is going to be 6.25 centimeters. So these are centered with a radius of 6.25 centimeters. And I'm going to put two charges on them, Q1 and Q2. Okay, and Q1 is going to be minus 7.75 picocoulombs, and Q2 is going to be plus 14.3 picocoulombs. And so what I want to know is what is the electric field in the center right there. Okay, so we about it, we say, well, what we got here is we've got an arc of charge there, we got an arc of charge here, okay, and we know this one's negative, that one's positive. We know that for an arc of charge at the center of the curvature, okay, that if this is some angle phi, then the electric field is going to be 2 k sub e lambda sine phi over r. Now, we had said for our case that's 1/4 of a circle, so the total angle is 90 degrees. That makes phi 45 degrees. Okay, so now what we want to do is we want to find the lambdas, because what's going to happen is that the electric field, because the arc on the left is negative, that means that E1 is that way. This one is positive, so E2 is away from it, so they're both in the same direction. We know that the total E is going to be E1 plus E2, and they're both in the negative direction, so that means that the direction is going to be minus I. Okay, so we need the lambdas. Lambda is Q over L. So I got an arc, and I put a charge on it. So the lambda is going to be Q over, well, that's 1/4. So that's 1/4 of the total circumference of the circle. Okay, so 1/4 of the total circumference of the circle. Okay, so 1/4 of 2 pi r. So that's going to be equal to Q over, or rather 2Q over pi r. Okay. So that's going to be my lambda right there. So lambda 1 is going to be equal to 2Q1 over pi r. Lambda 2 is going to be 2Q2 over pi r. Okay, so if I plug in the numbers right there, then that's going to give us those lambdas. But I don't really need that because I know that this is going to be what we got right there. So if I plug that into we know that for an arc that E equals 2 k sub e lambda, it's 2 k sub e lambda sine phi over r. So if I plug in what I got, 2 k sub e times 2q sine phi over r pi r. So that means the electric field is going to be 4 k sub e q sine phi over pi r squared. So that's going to be for that. So what we have here is that E1 is going to be equal to 4 k sub e q1 sine 45 degrees over pi r squared. E2 is going to be 4 k sub e q2 sine 45 degrees over pi r squared. Okay, and so if I plug in the numbers right there, then what I'm going to get is that E1, okay, and then E2. Now E1 is going to be in the it's going to be to the left here, so this will be a minus, and the answer comes out to be minus 16.06, or I guess I should round that to 16.1 newtons per coulomb I. And so E2 is going to be minus, because it's also, E1 here, E1 is that way because lambda 1 is negative. On the other hand, E2, okay, E2 is also going to be in the negative direction because lambda 2 is positive and it goes away from there. So it goes towards the negative. Lambda 1's negative, so E goes towards lambda 1. Lambda 2 is positive, so E goes away from it. And so that means this is going to be equal to 25.6 newtons per coulomb I. And so therefore the total E, okay, is going to be equal to minus 41.7 newtons per coulomb in the I direction.